Hi, I'm Mrs McTaggart. In this video we're looking at the higher topic of quadratic theory, and we're going to be looking at tangent to a curve today. So proving whether something's a tangent or being told it's a tangent and finding points of intersection. Prior to this video you should already have seen how to find the points of intersection of a line and a curve or two curves. So let's get started. So first of all, just remind you what a tangent is. A tangent is a line that touches a curve in one place only. So if a line and curve meet at only one point, then the line is a tangent to the curve. So to do these questions, you're looking for repeated roots. Remember, repeated roots meant that you've got one point of contact only. And to be able to do this, we treat it as an intersection. But first of all, we try to find the points of contact by setting y equal to y. Okay, so you're quite often asked to prove whether something is a tangent or prove that it is not a tangent. Now, there's two methods to this. Method one is we can use the discriminant, b squared minus 4ac. I use that one if method 2 doesn't work. So basically what happens in method 2 is we solve y equal to y, we factorise it, and if you get repeated roots, you probably then go on and solve it to get a point of contact. But if you're not able to factorise, or the repeated roots aren't obvious, or it's asking you to show it's not a tangent, we use method 1 and we use the discriminant. Because remember, b squared minus 4ac equals 0 meant equal roots at higher. So as I said, method 2 is recommended because it will prove it from factorising and give you the extra work you need. You don't want to have to constantly do the discriminant and then still go do method 2 anyway. So you'll see what I mean from my two examples. So here is example 1. We're asked to prove that this line is a tangent to the equation, to the parabola here, and we have to find the point of intersection. So our first step is we set y equal to y. Now, given the choice, you should always put the quadratic on the left-hand side, or the one with the highest power of x, just to save your rearrangement a wee bit. So I'm going to put the quadratic here. So 2x squared plus x equals 5x negative 2. So I'm saying just put the quadratic on the left because everyone likes to work to the left and bring your letters to the left. Okay, we're going to do that. So the 5x will become negative. So we'll have 2x squared. We'll have 1 take away 5x, gives us negative 4x. And then plus 2 will become, negative 2 will become plus 2, so we get that. Now we notice there's a common factor of 2 here, which will make our factorising easier. So that gives us x squared minus 2x plus 1. And when we factorise this, it gives us repeated brackets of x minus 1, x minus 1. And at that point, we write a little sentence. We write repeated roots. Now, repeated roots imply one point of contact. So line is a tangent. Just do that. Line is a tangent. Excuse my scrolly handwriting. So the line is a tangent at the point. Now I'm going to come back and do this in a wee second. Now if we solve those brackets, we know we get x equals 1. So if I know x equals 1, you then plug it into the straight line. So you do 5 times 1 take away 2. So we get y equals 3. So your coordinate of the point of intersection is 1, 3. So this method, the repeated root shows you what your x value is, and you just have to plug it in to get the y. If you are not getting a repeated root at this point and it's told you to prove it's a tangent, something has gone wrong in your rearrangement, or possibly you're factorising a common factor. So be aware you are looking for a repeated root at this line here. Okay, right, the second style is the one where it says, is this line a tangent? Or it might be asking you to prove that the line is not a tangent, or prove there are no points of intersection. I know, because I made up the question, that it's not going to be a tangent. But we're going to work through it the same as we did before. So we're going to set y equal to y. We're going to put the quadratic on the left-hand side. So we've got 3x squared minus 11x plus 5 equals 4x minus 1. We're going to bring everything to the left-hand side. So 3x squared. This will become minus 15x. And minus 1 will become plus 1, so we'll get a plus 6. Now, quick inspection. This is not going to factorise nicely. It's certainly not going to give me repeated roots. So we're going to go do the discriminant b squared minus 4ac. So b squared is minus 15 squared. Take away 4 times a is 3 and b is 6. And this gives us, I don't know why I've put that equal to 0, sorry. this gives us 225 minus 72, which is 153. So because b squared minus 4ac is greater than 0, it means there are 2 points of contact. There are 2 roots. So not a tangent. So the line is not a tangent. Okay, and if it wanted you to go find those points of contact, then it would be a trinomial that is nice and easy to factorise. I've got a funny feeling this one is going to be decimals though. So that would be the end to that question. You've proved it's not a tangent. Okay, but be aware they could ask you then to go find the points of intersection, but this one hasn't, so we don't need to worry about that. Okay, the third style of question is this one, where they've told you to find an unknown value, and they've told you that the line is a tangent already. So to find the value of m, we know the line is a tangent. We're still going to set y equal to y. I'm going to put the quadratic on the left-hand side again. And then we're going to bring everything over. And that will give us a plus 4. Okay, so the next step in this question is obviously this doesn't factorise. Because they've told you this is a tangent, we know that we can set b squared minus 4ac equal to 0. Now I'm just going to go to the side and write down what a, b and c are, because this one's a bit more complicated. So a is in front of the x squared, which is 1. Now b is anything that is in front of an x. So we've got a minus 2 and we've got a minus m here in front of our x's. And c is the number on its own. So when I do the b squared bit, I have negative 2, negative m all squared. Take away 4 times 1 times 4. And that equals 0. Now when you square out this bracket, there's going to be double negatives everywhere, so everything's going to become positive. So we'll have minus 2 times minus 2, which is 4. We'll have a plus 2m plus another 2m, so I'll have plus 4m. And then I'll have a plus m squared. If you're struggling to do that, feel free to go to the side and try it out, multiply it all out. But this is what we get. And then we have take away 16 equals 0. I'm just going to tidy this up. So I'm going to have m squared plus 4m take away 12 equals 0. Let's create a wee bit more space. And then this factorises. Numbers that multiply to 12 and add to 4 would be a 6 and a take away 2. Which gives us m equals 2 and m equals negative 6. Now the question asked, find the values of m for the line to be a tangent, and we have done that. So if m is 2 or negative 6, then the line is a tangent to the curve. And then hopefully that's me covered the 3 different scenarios of tangents to a curve for the quadratic stuff. Thanks for watching.